Is it time or shall we wait for some time? Do students come regularly or they come now? I think we're already late time. Okay, let's start. So what is gravitation? Are you familiar about force?
Yes.
What is force?
Force is equal to mass into
Acceleration. So force is cause of any motion. What is the meaning of force? See, if I have to set this into motion, I have to apply force. Okay. So force is cause of motion. Right? Force is cause of any motion. Okay. So understand force like this, and force. So if this body is in motion, right? Can everybody see this? If this body is in motion, right? So force is acting on it, but that force is applied by somebody outside. Okay. So force is applied by some external agency. Remember that. So body might be in motion, but the force which is responsible for the motion of the body is acting from outside on that body. Is that clear? So force is cause of any motion. Now force acts externally on the body. It's motion. Now this is the concept. So whenever any body is undergoing motion, some force is acting on it. Okay. Now look at this. What is happening? Look here. Is this pen moving? Is the pen in motion? So what must be causing? So when I'm jumping, am I going in the air continuously? I'm coming back, right? Why? Gravity. Somebody is pulling us down, right? So when I say gravitation, right? So it means motion due to gravity. Okay? So now, as I have given you these illustrations, so there is Earth, and you have seen, right? So if there is any object, if it is dropped, it will always fall downwards. Okay? Why it is happening? Now this is moving, so there must be some force acting on it. That force is because of Earth, and we call that force as gravitational force. Okay, or gravity. So yeah, what is gravitation? Motion due to gravity is gravitation. So that is general topic, and it is the gravitational force or gravity. Gravity acts means force acts. Gravitational force is acting. Okay. Causes body to move towards Earth. When dropped or thrown upwards. Got it? So dropped is this example, right? You throw it up, still it is going to come down. So when I have thrown it, it is leaving my hand at maximum velocity, right? Then there is a gravitational force acting against the motion. So it is slowing down continuously. So since it is slowing down, it will reach a position where it will have zero velocity. That's when it will change direction. Got it? So So when you throw a body horizon, when the body is thrown upwards, it yields with some velocity u. So at the top position, what will happen? V, and it will be 0. Okay, final velocity, whenever a body is thrown upward, it will be 0, right? Once the final velocity at the top becomes 0, but gravity, is it acting on it or no? Is gravity acting on the body? Always, it is acting all the time, right? So whether the body was here, during the motion, wherever, right? Every time gravity is acting downward only. Okay, there is a downward force due to gravity. Let's call this as Cbse. Okay, so motion is upward, force is retarding, right? That is why its velocity continuously decreases. And when a body is dropped, now when it is dropping, at 10, initial velocity now u is equal to 0, and it will hit with the same velocity with which it was thrown up. Got it? Now v will be equal to u in case of object thrown up. So for example, let's say it is thrown by 5 meter per second, goes up, it is 0, then comes down, it will hit the ground with 5 meter per second. Is that clear? Now, so all of it is happening because of gravitational force or gravity. Okay, is that clear? Now, whenever a body is undergoing this kind of a motion, what is the force acting on it? That is given by universal law of gravitation. Okay, there is universal law of gravitation which gives what is the force exerted by Earth on that body. Okay, one you already know what is the force. Force is given as mass into acceleration, right?
Yes.
And what is the acceleration? G. Acceleration due to gravity is called G. So whenever there is force, there has to be acceleration. And in this case, the acceleration is G. So so this is nothing but weight. Is also called as weight. Right? And weight is nothing but force exerted by Earth on the object. Okay? So what is the weight? Weight is the force exerted by the Earth on object. That is its weight. And what is its mass? Is mass and weight same thing? No. Mass is different and weight is different. Mass is the measure of inertia. Have you read about it? Huh? What is inertia and what is mass?
Inertia is the tendency of a body to move in its fast motion.
So inertia is the internal property of the body, okay, by virtue of which body maintains its last state of motion or of rest, right? So right now this bottle is at rest, so it will remain at rest. Even when I apply force, a gentle force will not move it. Now it is moved. So the initial opposition, because of its mass, right, is its inertia. So inertia is the opposition to the change of state of motion. Is that understood? And what decides that opposition? The mass of the body. Okay. So mass is the measure of the contents or constituent or matter of which the body is made up of. Right? But what is weight? Weight is force. Mass is a scalar quantity, right? So you need to understand this difference. Mass is the measure of matter or constituent matter, you can say. Come. Why you guys are coming like 15 minutes late? You have missed all the important concepts now. Yeah, because all the initial foundation you missed. Many, not only you, many have come late. Just 3 of them were present, right? Okay. So mass is the measure of constituent matter. Of the body. Okay. Which is measure of inertia. So inertia, and what is inertia? Inherent property of body to oppose change of its state of motion. Or of state of motion or of rest. Okay, is it understood? So if the body is, ठीक है लिख लो पहले इसको and let's see if we have any doubts. Those who have come just now, just sign it. All of you have signed it? You write your causes. So these concepts you should know. What is weight? Force acting on the body. By Earth's gravity. So that is weight.
So that G refers to the force of gravity.
Yes. Over here I just said Fg, but in general it will be F only. So you understand that, right? So here we are discussing about everything due to R. of G. Yes, please. You're a student? Okay, come. Why so late? क्यों? बॉस लेट नहीं आना, नहीं तो तुम लोग का बहुत लॉस होगा. अभी you are a second generation late now. People are coming late in generation now. पहले सबसे पहले जो टाइम पे बच्चे आए, फिर सेकंड में ये है.
ये भी मेरे साथ था, उसकी मम्मी को जल्दी कॉल लग गई, बंद करा.
अच्छा, ये मुझे गेम थोड़ा समझने में टाइम लगेगा. कहाँ है अटेंडेंस? Try to be on time. Already your lecture is only 45 minutes. So you're losing 15 minutes and you make it 15 minutes late, then it is only half an hour. So it's not worth your effort. ठीक है, next time से try करो. Okay, all of long. So almost it is full attendance. Arya Vasudev Patil. Your Arya Vasudev Patil. ठीक है, I think once. एक बच्चा है, दो है. तीन है क्या? All right. So far, whatever we have discussed, majorly we have discussed only 2-3 things. One is for motion, some force must be acting on the body, right? Now this is just because we are understanding motion, like what is causing the change of motion. Not that when for every motion there is a force required. Okay, it is basically to change the state of motion. Like this book is at rest, now I am putting it in motion, then force is needed, right? If this book was moving with uniform velocity, then there is no force acting, because if velocity is not changing, then there is no acceleration, then there is no force. Got it? Okay, that is first law of motion. What is first law of motion?
It stays at rest until we apply any force on it, it stays on rest.
So body continues to be in state of rest or of uniform motion. Okay, until and unless some force is applied on it to change the state of motion. So you have done all the laws, but you have to now understand it also. Okay, so you understood. So always remember, when there is no change of velocity, so in that motion is happening, but there is no force acting on it. Is that clear? So we say force is acting only when the motion is accelerated. That is when its velocity is continuously changing. Is that clear? So there are two situations when force is not acting: when the body is at rest, or when the body is moving with constant velocity, or when it is in uniform motion. Is that clear? Okay. All right. We also understood the difference between mass and weight. Mass is measure of the content, the matter. Okay, it's the matter content of the body. Whereas, so it remains constant anywhere. Whereas the same mass of body will weigh heavier or lighter depending upon what is the gravity at the place. Gravity is not constant. On Earth, let's say gravity is X. On Moon, gravity is X by 6. So a 6 kg, 6 Newton weight on Earth will weigh just 1 Newton on Moon. Mass is same at both the place. What the difference? That's why, like I'm not able to fly on Earth, but in a spaceship, I will with little effort I'll fly, because my weight is not as it is on Earth. Is it clear? So weight and mass are different. So weight is a vector quantity and mass is a scalar quantity. So weight is vector quantity. What does it mean?
It has both magnitude and direction.
And direction. In case of gravitational force, where is the direction? Downward, towards the center of Earth. Okay? Okay? Alright. Now this is the situation we have seen where the motion is straight line motion. Right? Now, let us understand the circular motion. Say there is a ball which is tied to a string and there is somebody, okay, who is rotating this ball in a circle like this. Like this. Okay. So now motion is taking place. Now this is a circular motion example. So is the state of motion changing at every point? Huh? What is happening? Let's say this is how the ball is moving. So let us say it is moving with the constant speed. Velocity is, let us say, 5 meters per second. Okay, every second it is, or 1 meter, let's say 5 is too high. So we have a 2 meter radius string and now we are rotating it like this. Okay. So it is traveling with 1 meter per second. So what is happening in this case? This is actually center, right? Let's imagine this is the center. Is there any force acting on the ball? Yes or no? Yes. Why? When do we say force is acting?
When some external.
Yeah, force has to be external. When do we say force is acting? When the body is undergoing change in the state of motion. So is the velocity changing here? Yes, velocity is changing because velocity is vector quantity. So at every point its direction is changing. It's along the tangent, right? You know what is tangent? You know tangent? See, if this is circle and this is radius, okay? Then tangent is a line which is perpendicular to the radius. Okay, so if the circle is moving in anti-clockwise direction, then tangent is this. So whenever you join the radius, tangent will always make 90 degrees. Got it? This will always make 90 degrees. Got it? So you'll learn about tangent in mathematics. Tangent. So now see, so if the direction wouldn't have changed, then this ball would go straight, right? Which means its direction is changed here. If you look at this arrow and this arrow, if I place this arrow here, so its direction is changed towards the center, right? Which means for the body to undergo circular motion, it has to experience force which is towards the center. That's why it is called centripetal force. Okay? So any body which undergoes circular motion experiences a force which is acting towards the center of trajectory. Got it? So any body undergoing circular motion any body which is undergoing circular motion experiences centripetal force. Okay? FC. Okay. Words. Words. center of its path. So this you have to remember. Without this force, no circular motion is possible. Okay, and you can verify this. So if you are rotating it like this, right, and if you observe it in slow motion in your head, thought experiment, right? Somewhere the string breaks. So let us say, just imagine 4 dots here, right? Okay, and let's say this is the direction: east, west, north, and south. In the plane, okay? In the plane of the board, right? So, like if the board is like page of your notebook, then north is upward, upper portion of your page. The ground, okay? This is not in space, it is in ground, right? So this is also in the plane of ground, okay? Now, imagine the string breaks and the ball was going in this direction here. You will observe that the ball will go straight, stone will go straight. Wherever the string breaks, it will follow that direction. Got it? That means why it went straight? Because now there is no FCP, string is broken. So this direction is not changing anymore. Because at every point, whatever is its last direction, okay, it is along the tangent at that point, right? So to get the direction change, the force has to act towards center. And what is that force called? Centripetal force. Without centripetal force, circular motion is not possible. Is that clear? Okay. So what I was trying to tell you is, this motion is also example of some kind of force acting on the body, and in this case it is centripetal force. Now what about motion of moon around sun? A moon around earth. This is motion. In that case, there was string, right? So there was tension, right? You'll feel the tension in your finger when you're rotating. So what happens is the muscular force is holding the string and the string becomes taut, stretched. So the tension actually in the string is because of the muscular force in your finger. Every time you're pulling the string towards yourself and the body which is rotating, okay, it is trying to go away. Okay, you will experience it. When you try to rotate anything, you'll feel pressure here. Okay, but you're still trying to pull it towards you. And that's how the body is able to make a circular motion. Is that clear? So that tension is providing the centripetal force. Who is providing the centripetal force? Tension in the string. So these are different types of forces, right? So have you heard of contact and non-contact forces? So what are contact forces?
Contact forces are like you have contact with the object in your life.
Like friction, okay? So whenever I'm trying to push it, it goes, it doesn't just keep on going, right? It stops, right? So how many forces are acting right now? One is the external, which I applied temporarily for a second, and then what force was acting when the body was in motion? Friction. So friction is between the surface, okay? So that is also a contact force. What are other contact force? Tension. Right? So this camera is hanging with this arrangement, right? So if this was not strong enough, it will break it and fall down, right? Suppose if I'm hanging with a rope, holding it, if the rope is not strong enough, it will break. So the tension is the force which is generated into the rope, and rope fiber has to be strong to hold my weight, right? So when I'm hanging down, my weight is always towards the earth. So the tension should be able to pull me up. Got it? So the tension in the rope is a different kind of force. It's not muscular force. right? So that is again contact. So the contact between my hand and rope, okay? So tension in the rope is pulling me up. Then if this rod is hanging through the ceiling, so there is tension acting at both ends. In the ceiling, which is holding the rod, and at the bottom of the rod, which is holding the fan. Got it? So tension is acting throughout. Okay? And it has to be same at every point. If it was not same, right, then the rod will get elongated. Got it? Okay. So you have to understand it. Then you have spring force. So many forces are there. Force in the spring, right? So take a spring, let it be. So these are the two examples of contact forces. What are non-contact forces? Contact forces. What are the examples?
The magnetic force.
Yes, magnetic gravitation. We are seeing it, right? So you can say electromagnetic force. So electromagnetic force. Gravitational force. Okay. So these are the forces which act at a distance, right? Now here, this was a contact force which was rotating the stone. What in this case? Hmm? If moon is undergoing circular motion around Earth, there must be some force acting on it. Which force is acting? Gravity. Understood? So it is a non-contact force. So now we understand this is such an important force, right? Which is responsible for us being bound to Earth, right? We are able to remain on Earth because of gravity. Like if we jump, it's not that we are like a missile, we have left Earth. No, we come back, right? So it is gravity. And all this motion of these planets, right? The tides, when you get tides in sea, right? It is due to sun and moon. Okay, force between the sea, water, and sun and moon. So it is the combination of relative positions of Earth with respect to moon and sun. That's how the tides takes place. Understood? So high tides are responsible because of that. So force which is at play is gravitation in all those situations. Is it clear? Force at work is gravity. Okay. You write it. So the way I've written is these are all concepts, and if you catch these concepts, now rest of the life will be very easy. So gravitation और कुछ है नहीं समझ में, ठीक है? So you got the perspective, I guess. So ask me if you have any doubts so far.
Sir,
It's okay, huh?
does that mean that gravity is proportional to weight?
No. Yeah, you can say that. Yes, if Earth's weight is, proportional to mass. So we'll see that when we do the relation. Just hold your question for some more time.
So the movement of moon is also centrifugal force.
Yes. And who is providing the centrifugal force?
Gravity.
Yes. Force of gravity. ठीक है, तुम लोग खुद से imagine करके भी answer कर रहे हो. This is what happens when your concepts are clear. You don't have to mug it up, okay? You have to understand. Physics becomes very easy when you change your approach to understanding rather than just by hearting the definition. You understand, then it becomes part of your life. Okay. Stress नहीं लेना है, कुछ भी question आता है पूछो. And there could be a lot of questions when the chapter is starting. So give yourself some time. Okay, be patient till halfway through. We are halfway through. Because initially everything will be a doubt. ठीक है, तो थोड़ा portion cover होने दो, बिल्कुल. Can I erase the left side of the board? We have only 5 more minutes. So how much is that force acting? Okay, that is given by universal law of gravitation. One is weight, mg. Okay. So what is the gravitational force? And not only the force acts between Earth and Moon. What it says is it acts between any two bodies which has mass. That's universal law of gravitation. Understood? So let's now understand what is the universal law of gravitation. So Newton had given this law. Newton's universal law of gravitation. Okay. So understand. Pause writing for a minute. Now suppose there are two bodies, okay, of mass m1 and m2. Right? Let us say distance of separation between their centers is d. Any object that we are learning, okay, it is a point object for you, right? Even though for clarity I am drawing a bigger circle, but this you imagine that it is a point. So whenever I say distance between the object, it is always distance between its centers, right? So any two bodies which has mass, there will be a force of attraction present in these bodies by virtue of its mass. Like the first body, okay, the force on the first body by the second body, and the force on the second body by the first body. So it will act in this direction. So along here. So there is a mutual force of attraction along the line joining the center. Okay, and that force, so F21 is equal to F12 is equal to F, say. Okay, that force is same in magnitude. Okay, but they are both pulling each other, just like tension. Okay, so the fan is attracted upward and the ceiling is attracted downward. Okay, is that clear? But the rod is bearing both of it. So the force magnitude is same, right? And that force is directly proportional to the product of the masses of the body, and it is inversely proportional to the square of distance between them. This is the law. Okay, so when we combine these two, we can write F is directly proportional to m1 m2 divided by these two. So when we remove the proportionality, it is replaced by a gravitational constant g m1 m2 divided by these. So this is the magnitude of the force which acts between any two objects which has mass. So if we know the mass of the object and the distance of separation, then we can calculate what is the force acting between them. And each body applies attractive force. Okay? This body is pulling this towards itself, and this body is getting pulled towards this body by it. So it's a mutual force. So forces always act in pair. For example, if you're trying to pull somebody, okay, you will feel that you're also pulled towards him. Like what is that? Tug of war game, right? Both are pulling each other, right? And that thing will not move if both forces are equal. Understood? So this is how it is, and that is why they are both pulling each other. Okay, they are both pulling each other, right? So what is G? G is universal gravitational constant. Universal gravitational constant. You can write the statement of the law from the book. Directly proportional to product of masses, inversely proportional to square of distance between them. Right? This is the universal law of gravitation. Okay, statement from book or notes, whatever. You can write yourself. So this is universal gravitational constant. And how much is its value? 6 point. How much is that? 77 into 10 raised to minus 11. What is it? Just check.
6.7 into 10 is
Into 10 raised to minus 11, right?
Yes.
Yeah. So force is Newton, distance is meter square per kg square. Okay? 6.77, or if it is only 1 decimal point. So you'll remember this later on. Okay? So just by using it repeatedly, you'll be able to memorize it. That's it. So which means I am right now attracting you, this table. But can we see any effect on it? No, because of this. Because our masses are not very high, right? And this factor is very small factor. So it becomes significant only at a big object level, like Earth or Sun. So their masses are too high. Like Earth's mass is of the order of 10 raised to 24 kg. It's very big. Okay? It's 10 raised to 24, very large number, right? So imagine. So any mass which is like able to negate this, then it will be significant. Okay? Our mass is how much? 100 kg combined. So still the force is 10 raised to minus 8 something. Not so much different. Okay. Alright, I think enough for today. So let the concept sink in. Come. So if you have any questions, I will clear the next. Yeah,
There are some in the surface area. इसके अपनी को बात नहीं कर रहा है